As steel heats up, it softens, losing its strength. This is how steel is first formed into the shape that you find it in. And while this is great for manufacturing steel, like they're doing below, this does become a little bit of an issue in the case of a fire. When a fire hits and it causes the steel in a building to reach this temperature, where you can see just how malleable and bendy it becomes, no longer able to carry the load it was designed for. In structural fire engineering, competent engineers can calculate this exact failing temperature. This is using the Eurocode method, a set of calculations that you can see here. These are in the ASFP yellow book. The calculations consider the shape of the steel section, the loads applied to it, and the insulation provided, as well as a bunch of other variables. Quite often though, all of this information doesn't reach down through the contractual chain, meaning not everyone in structural passive fire protection has the training, tools, or information to carry out these calculations. This was the latest conversation to come out of the ASFP Technical Group 1, which all the information goes into the yellow book. Critical temperatures. The temperatures at which steel elements can be expected to fail under load in the case of a fire. Previously, the industry relied on the widely accepted default figures of 550 degrees Celsius for columns and 620 for beams. And whilst these temperatures were appropriate for the older British design codes, they are not appropriate for the assumptions in the latest Eurocode for structural steel design. In January just gone, TG1 released its latest guidance in the 6th edition of the yellow book. And in it, they include a new set of default critical temperatures for use in cases where the full calculation isn't possible or practical. The new guidance replaces the historic 550-620 with an updated set of values, which are linked to the UK National Annex of the Steel Design Eurocodes, whilst taking into account different steel member types and support conditions. The new recommended default critical temperatures are 580 for three-sided beams, such as eye or hollow sections supporting a composite concrete slab, 550 degrees for four-sided beams not supporting slabs, as well as tension-only members such as hangers or braces, and 500 degrees for all columns, hollow sections, compression members, and trusses. These revised temperatures are intentionally comprehensive, and it's stressed that they should be used in conjunction with structures designed in accordance with the UK National Annex of the Eurocode. That being said, if you can do the calculation, of course, we recommend that. So, what do you think about these changes? And are there any other defaults that maybe we should be making a little bit more comprehensive?